Okay. Testing the microphone. Yep, there we go. It's good. Okay.
Laptop or gaming laptop. It's quiet.
Hello. Wait, that's worded right there. Fuck.
Steven, you're not muted.
Oh,
Get a sweeper.
Oh, hey, there's a security button. That's new. And live on YouTube. That's cool. That's cool. Manage participants. You don't. Okay. Fun. I have this. So anyway, in case you don't know, it is Passover tonight. Well, it was Passover last night, but it's Passover tonight. So, you know, once this lecture is over, I'm basically going to be baking more matzah. L'chaim. All right. So I'll wait for more. I'll wait for people to get in.
Sorry about this.
Matzah is bread that's basically been allowed to rise for no more than 18 minutes. Yeah, it's like a cracker.
Don't you mean cardboard?
Cardboard, yeah. Cardboard cracker. We're gonna add cinnamon sugar onto this one and see how that turns out. So yeah, Leeser is doing fine. He just doesn't want his diaper changed. So I'm just happy that my birthday did not conflict with Passover. Normally my birthday falls in Passover, so I'm very happy that it was before. No. It was my birthday a couple days ago. Monday, I think? 6th? So, let me go ahead and... Why didn't I tell us? Because you didn't have class that day. Alright, so... Let's see. Happy 40th. Very funny. Alright. But going back, somebody is asking about the extra credit and worth a specific amount of points. The extra credit, you post on the discussion... You do the assignment, you post on the discussion board. We'll give you credit for it in a bit. I think it's worth... I don't know how many points I put, but it should be like worth 15 points straight up on top of everything else.
I just have a quick question. It was too much to type out. For
Yeah?
the pig assignment, I was looking at like the thing today, and I realized I skipped assignment 6 when I submitted it. So I like re-uploaded all of them, including...
That shouldn't be a problem.
Okay. Thank you.
Extra credit is due by the end of the semester. So it's not too late to do it. Okay. Some other students are asking when the Regex was due. Probably sometime late next week. Let's see. The next... and depending on how this goes, we may or may not have another assignment, right? I think I've gotten what we need taken care of, and regex is a fairly large assignment and a fairly large material, so feels really difficult. So what part of it feels difficult so far? Yeah, it is a very new syntax. That is the big thing for it. But it is very, 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 very useful. That is true. It's distinctly very much not Python. But let's take a look at an exam from last semester. I'm going to go and find it and then pull it up. So intro to Python. Alright, so... Okay. So let's share the screen. Screen 1. Let's take a look at last semester's final exam. And this is the question I always give in every, whenever regex are taught. So it's worth keeping that in mind. So, write a function that will replace all strings matching the social security format, such as 111-222, -22-3333, with a redacted in a given file name. Save that result in a new file. You don't need to return anything. Basically, here, given a file name, and given an output, and given a target for output, read in everything and output everything, and then output the same thing, but with the social security numbers removed. And I do mention that basically, here is how you use regex.re.compile pattern to make a regex object, and then regex.sub thing used to replace, and then the target text to replace things used to, and that will replace stuff in your target text. And then how do you write a file? Here's how you open a file to write it, and then how you read that text to it. There you go. And then let's see what we've got in chat. Oh, I told the TAs to grade it, so yes, you need it you need the words.txt downloaded into the same directory because you're going to be reading that file. So it needs to be with your Python file. Right? Yeah, this will definitely be in the exam. This stuff. I mean, as you can see, it's part of this part. A lot of this stuff will be on exam 3. Let me close this for a second. And then, do I have a practice final? I did have a practice final. Cool. So one of the things that I had was here, write a script that, given a text file, returns all superhero words in it, which are words that end with man, woman, boy, or girl, such as Supergirl or Batboy. So, let's see. Yeah. There we go. Bum. Write a make username function. That wasn't... I'm just trying to see if there was more regex stuff in there that I had. But the regex is fairly straightforward once you get the handle on it. Which is pretty much all we're going to be doing the next couple weeks. So let's go ahead and getting started on regex. So, right, we were working on Batman regex, so let's go ahead and create a Joker regex.py. So remember, to do regular expressions, what we do is that we import the RE library, short for regular expressions. Now, we can use it directly and go like, hey, can you find all, right? So we can do re dot, and it works like this. Basically, you say Joker, so rather regex is equal to, let's go ahead and say re dot. So this is the pattern that we're creating to be matched. Dot re dot match, I believe. No, compile. So we first compile it, and then we compile a pattern. So let's go ahead and compile the pattern. Ha ha ha. I'm gonna just follow what we have over here in this textbook. Right? So we were going over different weird syntax yesterday. So we've got ha ha ha. And then let's go ahead and say this is our target. This is what we're going to be searching in. Let's see. Mark is the best Joker. There we go. Mark Hamill is the best Joker. This should not be a controversial statement at all. His ha 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 is amazing. Regex to compile that. And then we can say, hey, regex dot, then we can say regex dot match to create a match object. If match we print out what was matched. So we compile ha ha ha. Then we look for a match in target. And if we found one, we print it out. Else print okay. So we run this. Joker got a what? Really? So if match is equal to match find. Or sorry, it's not match. Sorry, it's not match. Match looks at the beginning for it. Looks at the beginning of the string. So here we're just looking for, so search is what we want. It's always the syntax that bothers me. So, you know, part of the reason I will give you the syntax to use it on the exam. It's just a matter of just remembering. A lot of it is understanding how to use this, because again, the syntax will vary from one, like the specific calls and how you call it to find stuff, that varies from language to language, but it's still very useful. Java string JDK 11. So let's look at the Java JDK. I know this isn't Java, but let's go ahead and see. This is the string object and all the stuff you can do with strings. So let's look at the replace. Let's see. The replace all. Notice that it says, this is in Python, not in Python, this is in Java. It says, hey, given a regular expression, replace everything that matches that regular expression with this string. So you can give this an empty string to do that. I don't know about the subprocess not making a connection. I've seen other students get that. I've never seen that issue before. Google that issue. Worst case scenario, uninstall, reinstall. But this regular expression will still be basically in the same format that you would use in Python. So now to remind you of how this, now to remind you of something we learned, we've got this modifier over here. So ha3. What does that mean? Any takers? What does it mean in the curly braces?
Doesn't that mean that it looks for 3 ha's?
Yeah, exactly 3 ha's in a row. Okay. And then note that if I do this though, it's not gonna look for it. It's looking for this. Ha! Because, right, it's looking for 3 of the preceding thing. Previously, because we had parentheses around it, right, everybody? Because previously we had parentheses around it, ha was treated as a single thing. Notice that it matched ha ha ha, and it returned ha ha ha, but not ha ha ha, because the, you know, because this is a substring of the, of this. Man, it is really, is it windy anywhere else, for anyone else? It is really windy where I am. Like crazy windy. Oh God. Is there a thunderstorm warning in Philly? Really? Crazy. Oh, I'm in Philly. I'm right outside of Philly. I am basically a Major League Baseball pitcher's throw outside of Philly, I'd say. Like, if you got a Major League Baseball pitcher and ask him to throw a ball as far as you can, he could probably throw the ball to Philly. Okay. Yeah. So, yeah, it is just windy. It's not raining cats and dogs yet. Although, what was that day where it was like, what was it, Tuesday evening?
2 nights ago.
2 nights ago, my wife could not get to sleep because, like, the thunderstorm basically was lighting up the sky like a rave. And I'm like, I'm just tired. I'm sleeping anyway. Now, yeah. So, my daily routine has basically been me taking care of a laser. And basically getting up and taking care of laser in the morning. And then my wife will eventually wake up. It's not like she has to teach. What? Usually she'll wake up before class, she puts in. If you're wondering what I'm doing and why I'm going on a segue, the online teaching pedagogy says you should basically break the monotony of it every basically 15-20 minutes or so. It helps refocus the class. So there's not just a reason for that. Okay, and last thing before we go back to class, is there any competition to say that basically Mark Hamill's best role was the Joker as opposed to Luke Skywalker? Because Mark Hamill is arguable. I'll take arguable. Something that definitely could be argued about. Mark Hamill played Luke Skywalker in the Star Wars series. And I liked Heath. It was really good. Yeah. Yeah. It's insane how much voice acting work he does.
And you want more peanut butter crackers?
Mm-hmm.
How many more? 2 more? Just 2?
I still have to see the latest Joker movie, so I will reserve judgment on that until I see it. But I've heard that the performance was quite good. So. I do have time, but I also have a toddler. Oh, God. We truly do live in a society. I understood that reference. All right. So now, let's go ahead and, so notice that basically we've got ha ha ha, that's a substring. It's looking for exactly 3. And if I look for this, ha ha ha, in there, it returns 3. We can discuss whether or not the world's becoming crazier later. Let's resume back this. Ha 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 is the first 3. So actually, which of these are we matching? Let's go ahead and print it out. Print match. Because no stuff, we've got 4 ha-ha-has. We've got, basically we've got 2 possible ones. Substring is basically a small part of a string. So this selection is a substring, the is a substring, best is a substring. It's just a string from within a string. It's just a way of saying it's some text inside another text. So you've got this ha-ha-ha, and you've got this ha-ha-ha. So which one is it matching? So let's go ahead and print out target. Let's go ahead and print out, let's see. Target up to 41. Up to, but not including 41. And we'll see basically at what point does the regex stop. So red up and... So from this we see that a regex is greedy. Basically, as soon as it, by default, as soon as it finds the first thing it can match, it goes, aha, I succeeded, and stops. As opposed to reading, you know, the second ha-ha-ha. Now, and again, with 2, it won't find 2. Now, there is some additional syntax we can use to modify this exact thing. No, there are not office hours today, but if you need to arrange to speak with me... Well, sorry, I don't have office hours. One of the TAs probably has office hours. So, if you need office hours or to meet with me individually, as people have pointed out, it's not like I'm doing anything... Well, tonight I'm doing anything. I have Passover preparation to do. It's like, so... you know, I haven't been, because of the quarantine stuff, I haven't been able to go out and get matzah, so I'm busy baking my own. So I have to do that for tonight, and then I have Passover Seder with my family in Chicago. Tomorrow, though, and the rest of the weekend, I'd be happy to meet with people. Alright, let me go back to this. So now, let's go ahead and say, let's do this. Compile ha 3,5. Yes, it is being recorded. I actually recorded before I logged on. So, boom. So, what this will do is that this will match between 3 and 5. Right? This should make fairly easy sense, right? This is not a hard extension. This is 3 laughs between 3 and 5 laughs. Make sense to everybody? Okay. See, does this work or no? Yep. This says match at most 5. So this is like kind of saying match 0 to 5? Yeah. It's basically saying match as many ha's as you can up to 5. Make sense? Actually, wait a second. Where's that gone? Did not work. Because, oh yeah, it should have stopped. Here, match 1 to 5. That should work now. Ha. 2. Yeah, let's stop printing out that part. 5 ha's. So this says match between 2 and 5. Pretty useful. If we do 4, comment and leave it blank. It says we will be able to... That says match at least 4. Just like this, the plus means this is at least 1. This means at least 4. So the plus can be rewritten like that. Please match at least 1 ha. And notice that it matched basically 1 ha. It matched the first one because it could. We tell it to match 1 to 5. Again, first possible match, it gives us the first thing that where this would come up true, it does. So 2 lessons to take around, right? You can specify a range, and regexes by default are greedy. It figures out the smallest thing it can do, And basically, as soon as it can return true, it does. Okay. So, let's see. So, so now let's go. So let's go and talk about this a bit more, right? Here, if we tell it to do, so here we were telling it to do. Oh, actually, sorry, matches 5. My bad. By default, I don't know why it was matching 3 earlier. I keep giving you bad information because I'm like, oh, this. So anyway, 3 to 5. Here we go. So this matches 5. This will match. It will match the first thing it can get to, and it went for as big as it could get. 3 to 5 over here, right? If I go for 3 to 4, it will match 4. If I match 1 to 4, it'll match. Ha. That's weird. So, Python is. Oh, you're right. That's why I'm getting confused. Stupid Mark.
Is your screen dirty?
No. No. It's counting the ha in Hamel. Thank you. Okay. I was wondering why this wasn't working like the way I thought it should. I was so confused. So very, very confused. All right. All right, let's go from 2 to 5. Notice that when I search for a ha between 2 and 5, it's going to look for the biggest one it can. Regexes are greedy. They match basically as big as it can. She learned how to code on her own. She can, we both went to Georgia Tech and taking a programming course is mandatory. So, now, notice that it matches the biggest thing. If we want to be lazy instead of greedy and match the smallest thing we can possibly can, we just put a question mark under there. And that means that instead of looking for the biggest a series of ha 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 ha, it'll look for the smallest. All right. Now, here's the other thing, which is possibly more important for the purposes of our class, which is the find all method. Search gives us the first thing. Find all gives us the strings of every match. So, now search does not find a... Now, search works a bit differently than matching. It's actually a lot simpler to... Sorry. Find all works a lot simpler. Let's see. So let's see. So right here, you've got search. Search looks for a match object. It will find the first one. Find all does not return a match object. Instead, it returns a list. Yep. I'll be uploading this all on GitHub to after class. Okay. Phone number. Find all dot py. Import regex. No. Oh, right. RE. Not regex. Okay. Import RE. Hopefully I didn't miss something up there. Okay. Target is equal to my phone number is 325-555-7062. In case you don't know anything. Okay, the video from Tuesday It says it's deleted on YouTube. It's probably still processing. I only just uploaded it like 5 minutes before class. So, will I be available for? Yeah, I can meet a bit afterwards. I suppose probably. So again, 555. By the way, anything where you've got the 555 series as the second series of numbers is a fake number. Let's go ahead and end this. Okay, my phone number is this. My office number is 123-555. My let's see, White House phone number. Boom. So let's make a regex that matches that. Okay. So let's go ahead and make a regex that matches this. Target. So regex is equal to re.compile to create our regular expression matcher. And we're looking for a phone number, which is, oh yeah, if we're dealing with slashes, it's always good to put a R in front, because otherwise we have to escape the escape character. Would keeping the parentheses change everything? I'd have to give the option of matching parentheses. So, right now I want the regex to be a bit easy to read, in case I want to put it in parentheses and to capture groups later. So it's just a cleanliness thing for when I'm actually building this regular expression. 3 digits, followed by 3 digits, followed by 4 digits. That is a US phone number. Not only that, but we get the country code of 1. USA, USA, USA. So, anyway, so this is going to look a bit different, but basically results is equal to regex dot find all print results find all find all and target, and boom, it found all the matches. So you notice that that's a bit simpler than using, this looks a heck of a lot simpler than using the, than using a match object. And for a lot of cases, using find all is very, very easy. But, it's great until we have to deal with groups. So, let's see. So let's go ahead and separate this out into groups. So area code, first digits, and second digit. And this is why I didn't want to do the area code. Didn't want to keep the parentheses up here, because to capture that I would have had to do like this. And that makes it this part harder to read, and I wanted this part to be easier to read. So now, if I run this, it captures what was caught in the parentheses. So it returns a list of tuples. So here, notice that it breaks it. It gives us everything that was matched broken up into the groups. So find all. If you don't use any groups, you're going to find all the matches. If you have groups, oh yeah, totally. Sorry, and I'll do that in just a second. If you have groups, then it returns a list of tuples of strings. So in other words, it returns a list of a bunch of groups. So let's go ahead and make it nicer to format, like Celine asked for. So for, I mean, it's just a list of strings. So all you have to do is for results. I'll learn how to type one of these days. I swear to God. For result in results, print result. And let's go ahead and remove these parentheses. Just like that. Makes sense? Yeah, it's a very easy way to do it. Basically, create your regex and then ask it to find all the strings inside target. Fantastic. So we've shown you how to do so to review the character classes that we've done. /D, lowercase, finds any digit that's 0 to 9. /W is anything that's a word character. Anything that basically you can use in the best way to describe it is that if you can use it in a variable name, it's a word character. So letters, numbers, and underscores. Basically anything that is a variable, part of a variable name in Python or any other programming language. No punctuation. S is any white space. So your spaces, your tabs, your new lines, and the like. And if you capitalize it, you invert it. So you can create, and as I mentioned also, you can create character classes as well. So 0 to 5. So in brackets, you can do 0 to 5. This is much shorter than typing 1 or 2 or 3 or 4 or 5, right? The bar is for or. So there is no, so they're mentioning that basically there is no /D, you get digits. W gives you digits, letters, and underscore. There's nothing standard that just gives you letters, but it's fairly easy. Just use A to Z, which we'll get down there next. So let's take a look at this regex, which is pretty cute over here. 12 drummers, 11 pipers, 10 lords, 9 ladies, 8 maids, 7 swans, 6 geeks, 5 golden rings, 4 birds, 3 hens, 2 doves, and 1 partridge. I should mention that our Seder has a, it is I have a lot of family in Chicago. A lot of family, like 40 family members, and normally it's a big get together and a lot of stuff. And yeah, there's a full-on musical production, typically doing parodies of songs. 2 years ago, they basically did Passover themed parodies of Hamilton, which was fantastic. Last night it was a Christmas theme, so they took a lot of Christmas music and stuff from Frozen and turned it into Passover music. It's pretty good. So it was a lot of fun. Oh, and there's 2 nights of Passover, so they prepare 2 different shows. I don't know why. All right. So anyway, so this matches. So let's see what this matches. /D, that's a digit. This says matches any number of digits. It is an insane amount of commitment. Digits, on some number of digits, followed by a single white space, followed by some number of words. So notice that it finds, so let's go ahead and grab this. All right, here's our Christmas regex. / any number of digits plus any number of spaces plus any number of stuff. Let's see. Let's just simply put this over here. 7 swan. View. Toggle word wrap. There we go. So 12 drummers, 11 pipers, 10 lords. So basically, this matches 12 drummers. So the first thing it matches is 12 drummers, up to but not including the comma, because it says, okay, I've matched as many digits as I can. Now let me see. Do we have a space character next? Yes, we do. We have some white space character. Okay, I found one of those. Is the next thing a letter? Awesome. It is. What it wouldn't match is this. Okay. Oh. I should probably put a print around this. Right? So it goes down and it matches. But if I put in 0, and if I put in 0, I don't know. What's an appropriate thing to put for 0? 0 coal. 0 pieces of coal. That's actually a great example. It's going to match 0 pieces. It's not going to match 0 pieces of coal because it'll just match 0 pieces because what it's looking for is any number of digits followed by a single space. So if I put in multiple spaces like that, no go. If I put in a single tab, well, it's a bit of a trick, actually. And put in a tab space, an actual tab, because a lot of IDEs, when you're working with Python, it's going to replace it with spaces. So now it will match that because the /t, that's a tab character, and then it'll match pieces of coal. Actually, no, we'll match just pieces. It won't match pieces of coal because space is not matched by the W. Does that make sense? Why it's matching the number and pieces, but not pieces of coal. And why it's matching everything else. It's matching all these, and it's not including the commas. Any questions about this example so far? So, a lot of times we won't be able to what does the plus mean again? Plus means at least one. Plus means at least one of the preceding. So this means at least 1-digit character. So it will match 12 drummers. It'll match 2 drummers because we've got at least one of them. It won't match that. It'll match some absurd amount of drummers. But you need to have at least 1 digit. Now, if I change it to this, the clean star, that means at least 0. So if I did this, now I'll match that. Clean star is tricky. We'll get into more detail about it. You don't find yourself using it too often. Alright. So, let's see. So if we were to do this one, let's see. So, yeah, you can match. So we can create our own character classes, I've pointed out last time, because a lot of times /D/W and /S are too big for they're overkill for what we need. So for example, AEIOU will match an eval. So compile it and then do find all on RoboCop eats baby food. Baby food. It'll match all the O's, the E's, the A's, and that. Now, as I mentioned last time, you can also create your own character class by jumping into any Dungeons and Dragons game. Wait, no, different character class. A-Z, A to Z, 0 to 9. This will match any kind of range. If it's inside of square brackets, by the way, it's interpreted as normal. So, one of my favorite things to do is to create a character class that will find punctuation, right? So I could find punctuation by doing punct regex is equal to re dot compile r and I don't have to escape any of these suckers because even though they're normally special characters, and the reason is that if they're inside brackets, they mean you literally want to look for any of those. This is also a pretty cool thing that we can do over here, by the way. So let's go ahead and work with this Christmas regex again. We're going to create our own character class here. A-E-I-O-U, right? And this is going to print out all the vowels in this, right? So find all the vowels in this. Make sense? So this is the other cool thing you can do with character classes. Just like how you can invert a slash D, how you can type in slash capital D to make no digits, or to make, to flip it to basically anything that's not a digit. We can totally do caret A-E-I-O-U, and that will match everything that's not a vowel. It says any single character that's not a vowel. So it matches the 1, the space, the D, the R, but not the U. It matches the M, the other M, the R, the S. Skips over the E. Which is pretty cool. Okay. I've talked about this. We'll get into that later. Let's see. Actually, why not now? So the caret and the dollar sign. The caret's primary use is there. So that's an excellent question. I have no idea why the design choice was made like this, but inside the brackets, it's saying any one of these characters inside the brackets, and the caret just simply reverses the entire selection. And I mean, a not A, if it was not A, that would be implied by having an... If the not only applied to A, it would by default hold A-E-I-O-U in it. So I think that's the reason why the not inverts the entire selection. So, I mean, I don't know how old regex is old. Let's go ahead and look at regular expressions on Wikipedia. The concept arose in the 1950s, and the syntaxes... Different syntaxes have existed since the 1980s, POSIX being one standard. That makes me feel old, suddenly realizing that 1980s is the is 40 years ago. Like, for the longest time, 1980 was 20 years ago, and now 2000 is 20 years ago. I feel old. All right. So, begins with hello. So using a caret outside, not inside character, basically means the beginning of a line. So here, if you look for begins with hello and you compile it and you look for it in hello world, it'll match it. It'll match begins line hello. But if you do, if you look for hello and he said hello, it's not going to match it. The dollar sign basically means ends with. So /D. Your number is 42, it will match the 2. And then you can say basically, this means basically give me an entire string that is just made up of digits. And finally, this one's fun. The carets you won't use too much but they're useful for your homework. Basically, where you want to go line by line and say, okay, if I want to find a 4-letter word, basically, then basically I want it to have 4 letters between the caret and the dollar sign. So let's go ahead and make one more regex. The @regex. re.compile .at. So the dot is the wildcard character. it matches anything at all. Any single character. So here, this will match anything that follows the pattern of any letter followed by a followed by a T. So cat, so it matches cat, hat, sat, lat, because that's blank AT, and then mat. So if you think back to like the question for the practice exam, from that basically was match anything followed by a C followed by anything followed by a T. You could have written a regex that was C dot T, and then use that had you known how to use regex. Sometimes you want to match everything in between. So this is a very powerful and also very dangerous tool. Dot star. It gives us literally everything, right? So think about this for a second. What is the dot? Dot is any character. The clean star means 0 to infinite. So here, let's go ahead and look at this. Right, it says first name. This is matching first name. This one's a good one. Really good example. So here's our name regex. So let's go ahead and search for our match object like we were doing before. First name Al, last name Zweigert. That's the author of the book, by the way, that we're currently looking over. Okay, so print mo.groups. Alan Zweigart knows that these guys are in groups. So saying first name followed by a space. So it's saying match first name, colon space, followed by any number of characters. That's then followed by a space, and then followed by last name, then followed by any number of characters. So now this works because we're looking for any number of characters out. Right? Right? Any number of characters. So, any sequence of characters, this will match. Oh man, it's still windy. Last name. So, again, it will work also on my name. Andrew Rosen. So that's a really powerful tool. So the big thing is that this is greedy. It will try to match everything. Basically, it will match as much as possible. Whoops. So let's see. So let's say we do Andrew last name. Wait, what am I putting here? Oh crud! They might find out I don't know any of this stuff, right? But this is a greedy expression. So this dot star. Notice that it has. We have Andrew, right? We have first name over here, then Andrew, and then, but the dot star here, right? It says dot star anything followed by last name. But notice that we have two last names over here. We have the last name over here. Wait, what am I putting here? Oh crud! They might find out I don't know any of this stuff. And then they have over here last name Rosen. Okay, but notice that it goes up and grabs basically all of this as part of the first part. And this is because it's, again, remember that Regex by default is greedy. It tries to match as much as possible. So it matches the biggest selection it can before it hits a last name. So on the other hand, so how do we make it not greedy? Same way we did before, by using a question mark. So now notice that since this is not greedy, it matches Andrew, okay? So it matches Andrew, and then it finds the last name, and it says, okay, I'm not greedy, I'm being lazy, so I stop matching over here, and then I match last name, and then everything else that comes after it. And now if I put this over here, it'll do Andrew, followed by last name, and then notice it doesn't return anything there. It's being lazy. Dot star means 0 or more of anything. Well, it's lazy, so it's saying, I don't want to find anything, so I'm done. The only reason it doesn't do that there is because it needs to find enough so that it has a space followed by a last after it. So it makes very big difference. So let's take it over here, right? Compile this one, which tries to look for the shortest thing. So here it says, find a open. Here's how you can read this one. Look for a less than sign. Then look for anything, and then fill it up with everything until we get to a greater than sign, and then stop. So here we have to serve man for dinner. And what it will do is that since if we're looking for at it lazy, it will search for to serve man. But if we try to get as much as possible, if we read this one, it says, find the biggest string that matches this pattern. A less than and a greater sign, and then fill it up with as much stuff as we can between it. Right? That's what the difference between using the dot star makes. So, big thing to note here is that it says the dot star will match everything but the /n character, the new line. And when you compile a regular expression, you can give it some options. Like over here, let me go ahead and go over here for a second, comment all this out. We can compile our regular expression with certain options. Okay. Here's one option that's probably going to be very valuable to you. re.I. And that will compile it with, that basically compiles it with case insensitive mode, meaning it doesn't care whether you use capital spaces or lowercase spaces. So that saves you from having to convert stuff from uppercase to lowercase or whatever, or having to figure out or put in extra stuff for uppercase and lowercase. So that's useful. Another one was re.all. And what that was saying over here, what it will do is that it will match all characters, including new lines now. So re. So notice the difference over here. We've got re.compile.star. So in other words, it's saying match the biggest string I can. And then it says, serve the public trust, protect the innocent, uphold the law. That group. This guy really likes RoboCop. So here, notice that if it searches for it, and the first thing it's going to find is serve the public trust. And actually, it's only going to search the public trust because by default, the dot does not match a new line. So it matches everything but a new line. If you compile with re.all, it's going to match the new lines in it. So, all right. So here is the review of all of the symbols that you have. This book is available for free at automatetheboringstuff.com. And is a very helpful resource. So let's see what else we have. Yes. Now, my personal favorite thing is that we can finally talk about how we can write the... Actually, I don't need to send you to a link on Canvas because it's already there in your syllabus, actually. This is, in your syllabus, you have a link to not only the textbook for this course, but I also have recommended... I put in, like, here's some other resources you can read. And this was one of them. So if you need it, just look in the syllabus. So, and we hadn't touched this textbook before in class. I just had put it up as a possibility. So regular expressions, this is the best part about it, which is basically, let's go ahead and let's go ahead and basically write a text document, right? Let's make a nice little text file over here. ssn.text. Let's go ahead and say Alice let's just go with, Alice Hackerman, and her social security number will be 111-22-3333. Bob Hackerman, 111-22-3332. Thank you. Somebody put it in the chat for us. Alice and Bob, Carol Hackerman, Dan, right. Et alia 927 113 5982. Et alia, just a joke on, or let's go with et alia, a joke on et al. And others. So this is a file that for some reason HR has stored on their computer. Right? So if we want to write, so let's go ahead and write a program that first, let's go ahead and find and see and print out all the social security numbers using Regex. So ssn dot finder.py. Right? So let's go ahead and just find something that does this. So first, let's open up this file. open it up in read mode, and we're gonna find it. Okay, and because we're running short on time, I'm just gonna show you the sub method here. So what we're gonna do is data for line in data print line, right? And it printed out all of it out. Let's go ahead and do print. Let's go ahead and strip the line as well, because it has that trailing white space. There we go. I went ahead and made this number. What protects us all this sort of information? Absolutely nothing, pretty much, other than constant vigilance. But seriously, there's other stuff like so for instance, the way your password is stored on a computer, it doesn't actually. So on most computers, the way it does. And some websites don't have good developers that do this. The way is that they never actually store your, they don't actually store the password. They store the hash of the password. So they throw your password through an awesome function, and it creates a unique number. And the thing about a hash function is that if you throw a number into a hash function, you will get a unique identifier, and it's always going to be the same unique identifier. But if you try to figure out from that unique identifier what the original thing that came in was, you can't. You can't. So typically what goes on is that we use something called salted hashes, which adds a little extra twist in there. But what we do is that we basically, essentially, when you log into something, we don't actually check the password against some big file that's insecure. What we do is that we take your password, throw it through some function, and then we see if that function's output matches what's stored with your username. So, similarly, the best way to secure social security numbers and private information is, well, honestly, I'm not a security guy for that, but it is. Oh, the question was just a question for thought: how are all this sort of private information protected? For example, hackers are obviously extremely good at using code to get through things. I'm assuming, so it protects all this information. At the end of the day, most hackers aren't really that skilled. It's just that people are very lax. It's primarily, I would say, it's most of these stuff that gets leaked is not because of any super secret skills, but because just security was lax. Going back to the whole salted hash thing, I like the textbook maker Wiley, and I don't feel guilty at all hammering about this because I hate textbook companies. Yeah, that's actually pretty much what that is. So, that's okay for temporary passwords. Temporary passwords are okay. But the idea here is that when I click on forget my password, actually it's not that okay. It really depends on the size and scope. But, if I go and click on forget my password from Wiley, what it does is that it emails me my password and tells me to log in. And that means that they can email me my password to let me know what it was. It means they stored my password, which means that if they get hacked, they can retrieve it. So the best way so this is the whole, the best way to not have that stolen is to not have that in the first place. So that's why... So that's where the whole hashing thing comes in. Now, this is basically you doing... So what I'm going to show you is basically part of doing triage and that kind of stuff. So here's a file with all that stuff. So let's go ahead and find all the social security numbers, okay? So SSN, let's go ahead and import RE. Import RE. Okay. Now let's go ahead and make an SSN regex. Is equal to RE dot compile. The regex we are going to compile will match the social security number, which is a pattern of 3 numbers followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers. So we are looking for this. Now we learned about find all, how to find all that stuff, but honestly finding them isn't what we need. What we need to do is completely rip them out and replace it. So we want to sanitize this. So, but let's go ahead and basically print out all the stuff we find. So print SN regex dot find all. No. Next week we're gonna do a couple of in-class exercises on this stuff. Find all. So we can now print that out. So there we find our social security numbers. Not that great. So instead what we can do is now we can, instead of using find all, what I'm going to do is use sub. Sub is amazing. Because what it does, it says, hey, anything that matches this sub... I want to replace anything that matches this regex with this string I'm giving you. Redacted. And I'm going to search for it inside line. Okay. So now let's go ahead and clean this up. Output is equal to... So let's go ahead and make a new file. Create it into write mode. So I'm creating a new file, creating it into write mode. And now what I'm going to do is I'm going to say, hey, for every line, I'm going to take out the regular I'm going to create a new string that's the same, but with the social security number being replaced with redacted. And then out file line. Out file dot write line. There we go. And there you go. Very small script. Very, very small script. Very amazingly powerful. And basically, this is an automated find replace function. It wouldn't work on any file of any size, and as long as social security numbers fell into that pattern, it would strip them out. We can go a bit further, right? We can say, what if somebody sent in their social security number like that? We can make and what we'll do is we'll just make the dashes completely optional. Quick check, boom. Overwrite the file. Right? And it fixed it. So, yeah. Regexes are great for dealing with stuff like this. Or if you're just trying to find stuff that matches a pattern. They're very, 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 very powerful. And very useful. So, if you need it, so some of you mentioned, I can stay behind for a bit. But, let's see. let me look at what the project phone number and email address extractor. Right. So, well, yeah. That sounds like a great thing, and then I can tie this into. Yeah. Okay. I mean, I'm gonna upload this onto GitHub. So, so the next thing we're gonna do on Tuesday is that we'll do a small project using regular expressions. What we're gonna do is that we are going to write this phone number email address extractor, and then we're gonna extend it so that it actually works on doing stuff online. Question mark is optional. So the question, why did I ask the question mark again? So it means either it has a dash or it doesn't. I don't care. If it has a dash, great, I'll match it. If it doesn't have the dash, I won't match it. That way, it matches this. So then we're going to extend this to showing you how you can read some websites and crawl and basically download the HTML, and then we can extract names and phone numbers, phone numbers from there, and email addresses. And basically we can see, wait a second, this is how spam bots build their networks, and why everybody puts the whole, why people write it out like, this is my username at this .edu, and then you can see, wait a second, I can build a regex that accounts for that as well, and that's not that hard. So, regexes are extremely powerful. The limits of their power are when you have to ask it to remember something. So, for instance, regexes cannot match arbitrary nested parentheses of arbitrary def. Now that sounds like a very specific example, but this is because it gets into the 4000 level class of computer automata, which if you ever get the chance to take it, you should. And you get to learn about stuff like and basically, you can see that regular expressions and discrete finite automata, also known as state machines, which are these basic flowcharts of the same thing. And then if you give them a little bit of memory using something called a stack, you get yourself a stack machine, a push-down automata, or stack machine, and the language that describes that is a context-free grammar. If you add one more stack, you basically get yourself a Turing machine, which can be described using a Turing-complete language. So, this is kind of the core of a lot of theoretical computer science that we get into. And it's really cool. Alright, so I'll go ahead and stop sharing. If you have questions, I know that some people asked, I can stay behind and answer some questions. Let me go ahead and stop sharing, stop recording.